We are asked, what could be the equation of p? And we have the graph of our polynomial p right over here. You could view this as the graph of y is equal to p of x. So pause this video and see if you can figure that out. All right, now let's work on this together. And you can see that all the choices have p of x in factored form, where it's very easy to identify the zeros, or the x values that would make our polynomial equal to 0. And we can also look at this graph, and we can see what the zeros are. This is where we're going to intersect the x-axis, also known as the x-intercepts. So you can see when x is equal to -4, we have a 0, because our polynomial is 0 there. So we know p of -4 is equal to 0. We also know that p of, it looks like 1.5, or I could say 3/2. P of 3/2 is equal to 0. And we also know that p of 3 is equal to 0. So let's look for an expression where that is true. And because it's in factored form, each of the parts of the product will probably make our polynomial 0 for one of these zeros. So let's see, if in order for our polynomial to be equal to 0 when x is equal to -4, we probably want to have a term that has an x plus 4 in it. Or we want to have a product that has an x plus 4 in it, because x plus 4 is equal to 0 when x is equal to -4. Well, we have an x plus 4 there, and we have an x plus 4 there. So I'm liking choices B and D so far. Now, for this second root, we have p of 3/2 is equal to 0. So I would look for something like x minus 3/2 in our product. I don't see an x minus 3/2 here. But as we've mentioned in other videos, you can also multiply these times constants. So if I were to multiply, let's see, to get rid of this fraction here, if I multiply by 2, this would be the same thing as, let me scroll down a little bit, same thing as 2x minus 3. And you could test that out. 2x minus 3 is equal to 0 when x is equal to 3/2. And let's see, we have a 2x minus 3 right over there. So choice D is looking awfully good. But let's just verify it with this last one. For p of 3 to be equal to 0, we could have an expression like x minus 3 in the product, because this is equal to 0 when x is equal to 3. And we indeed have that right over there. So choice D is looking very good. When x is equal to -4, this part of our product is equal to 0, which makes the whole thing equal to 0. When x is equal to 3/2, 2x minus 3 is equal to 0, which makes the entire product equal to 0. And when an x is equal to 3, it makes x minus 3 equals to 0. 0 times something is going to be equal to 0.